All right, continuing on with our more complicated examples involving tangent and secant, let's go ahead and evaluate the indefinite integral, which is the integral of tangent to the sixth of x dx. So note, in this case, we have an integral of tangent to the sixth of x times secant to the zeroth of x dx. This was an even power on tangent, 0 on secant. This was a case 4. So what was recommended with case 4 was peeling off one copy of tangent squared and converting it to secant. So we are going to take the integral of tangent to the sixth of x dx. Rewrite that as the integral of tangent to the fourth of x times tangent squared of x dx. That tangent squared of x is simply secant squared of x minus 1. So we are looking at the integral of tangent to the fourth of x times secant squared of x minus 1 dx. This becomes the integral of tangent to the fourth of x times secant squared of x dx minus the integral of tangent to the fourth of x dx. This integral of tangent to the fourth x times secant squared x dx. This is actually a case 1 integral that is already perfectly set up for u substitution. So for that one, we can do u equals tangent, then du is that secant squared dx, and we're ready to go. This integral of tangent to the fourth x dx is another case 4 integral with a lower power. So we have the integral of tangent to the fourth of x times secant squared of x dx. We're going to set u equal to tangent of x. Then we have our du is secant squared of x dx. So we are looking at the integral of u to the fourth du, otherwise known as 1/5 u to the fifth plus c, or 1/5 tangent to the fifth of x plus c. Our next component is our integral of tangent to the fourth of x. So the integral of tangent to the fourth of x dx. We are again going to peel off a tangent squared. So this is an integral of tangent squared of x times tangent squared of x dx. We are going to replace one of those tangent squares with a secant squared minus 1. So tan squared of x is secant squared of x minus 1. So we are looking at this integral of tangent to the fourth of x dx is equal to the integral of tangent squared of x times secant squared of x minus 1 dx. So we have the integral of tangent squared of x secant squared of x dx minus the integral of tangent squared of x dx. So we are looking at the integral of tangent to the 6th of x dx is equal to our first component, that integral of tangent to the 4th secant squared x dx became 1/5 tangent to the 5th of x. Then from there, we were supposed to subtract off the integral of tangent to the 4th of x. So we are going to subtract off, now integral of tangent to the 4th of x became the integral of tangent squared of x, secant squared of x dx, minus the integral of tangent squared of x dx. So this becomes 1/5 tangent to the 5th of x minus the integral of tangent squared x, secant squared x dx, plus the integral of tangent squared of x dx. Once again, that integral of tangent squared x cosecant squared x dx, we have our even power on secant. That is again back to case 1. Integral of tangent squared, one more time, we are at case 4, even power on tangent with no secants available. So we are going to do 2 more integrals. The integral of tangent squared of x, secant squared of x dx is perfectly set up for u substitution. We will do u sub. We will set u to be tangent of x, du to be secant squared of x dx, therefore. So we have that this integral is equal to the integral of u squared du. So we get 1/3 u cubed plus c, or 1/3 tangent cubed of x plus c. The other integral we needed was the integral of tangent squared of x dx. So we have the integral of tangent squared of x dx. We are one more time going to apply the fact that tangent squared is secant squared minus 1. So we have secant squared of x minus 1 dx. Integral of secant squared is just tangent of x. Integral of -1 becomes minus x, and then we have plus c. So going back to our original integral, we have that the integral of tangent to the 6th of x dx is equal to, we had 1/5 times tangent to the 5th of x. From that, we were supposed to subtract off the integral of tangent squared x, secant squared x dx, which that was just 1/3 tangent cubed x. So we will subtract off 1/3 tangent cubed of x. And then we were supposed to add on the integral of tan squared of x dx. So we will now add to that tangent of x, then minus x, and of course, plus c. So again, this required multiple iterations of various cases It's a lot to keep track of, so I do recommend going back periodically and just writing out fully where you're at for that integral you're aiming for. Just a quick note. You should be able to do case 1 and case 2 comfortably. You should know the process for case 3 and case 4. But in reality, nobody really does those integrals by hand these days. So you should be able to do integral of secant cubed. So you should know the process and be able to completely solve something like integral of secant cubed x dx, or integral of tangent to the 4th x dx. For more complicated ones, you're welcome to use integral tables. So again, case 1 and 2 for these, you do pop up. You should be able to do them, and they're quick. U substitution falls out relatively quickly. Case 3 and case 4, especially ones where you keep doing them and more and more and more integrals pop up, get annoying very quickly, and you're welcome to use integral tables to do them. So that is it for the trig integrals. Your next topic will be what is called trig substitution.